Steve Richter from Delaware DOT.
I'm here today to talk to you about an issue we had in Delaware. We have it typically several times a year, every year. This year we had 4 incidences where we had to stabilize abutments due to sinkholes that were developing behind the abutments, creating maintenance issues. We had to, in some cases, close the bridge, do emergency repair, got in there with a contract to repair the bridge. In several of the cases, we used our traditional method of repair, and that is to use sheet pile to stabilize the abutment behind the existing abutment. We drive new sheet pile. This one case, we used foam injection, which I'll get into. What happens is the problem is we have a loss of fill behind the abutment. Holes develop in the steel or the timber sheeting behind the abutment, and the material starts to wash out, and it reflects up to the surface, and we get sinkholes. And sometimes those sinkholes are pretty extensive. The material can wash out underneath of a concrete pile cap or a concrete abutment, and we had a couple incidents where that happened this year also. Some are slow or gradual and require regular maintenance. In one of these cases, in the actual one we use a foam injection, it was slow and gradual and required maintenance over about 5 or 6 years now. We've been repairing that hole. Some are more catastrophic and we just discover them all of a sudden, and this is an example of one that's more catastrophic. We didn't have any like this year though. That's the governor and previous Secretary of Transportation. And as I mentioned, our traditional method to repair these has been to install a sheet pile wall behind the existing abutment wall and seal that area off. And in some cases, we install scour protection. This is usually done in the wet because it's more disruptive to try to dry that area out. You end up driving sheeting around there anyway. It has a long lead time for permits. Not feasible for bridges with small vertical clearances. As I mentioned, this year we did 4 different locations where we had loss of fill behind the abutments and we had sinkholes develop. 3 of the cases we used our traditional method of repair, and in the bright red star there we tried something different and we went in with the foam injection. This was the first one we did this year, and this was done in April. This is on Slaughter Beach Road over Cedar Creek. It's east of Milford, Delaware, on the Delaware Bay, pretty close to Delaware Bay. This is a picture of the bridge. This is a picture of the sinkholes that developed, and they developed on both sides of the bridge. Our repair method was to come in, install steel sheeting behind both the abutments and wing walls behind both the abutments. On top of the sheeting we installed a concrete pile cap, which was positively connected to the existing pile cap. So in effect, completely sealing off that area. And the reason for this, we had to do this, is because this sheeting that's here had holes in it, which were detected by underwater inspection, and they were very obvious. The bridge was built probably 50, 60 years ago. Rebuilt probably. There was another bridge there, I'm sure, before. The sheeting just begins to deteriorate over time. Other than that, the bridge is in pretty good shape. It doesn't require replacement or anything like that. We come in with a maintenance project to install the sheeting, and here you can see the sheeting going in. This is the second project we did. This is on Round Pole Bridge Road over a tributary to Broad Creek, popular fishing and crabbing area, among other things. And here you can see the sinkhole on this side that has been repaired numerous times. There's another one on the other side. Once we got in there and started working on the bridge, the sinkhole here, this guy, our inspector, has pushed his tape under 15 feet, pretty extensive. It's just being held up by hot mix repair over time. And our repair method was to install sheeting behind the abutment and wing walls. This bridge really didn't have a sheet pile abutment installed when it was built in the early 60s. It just relied on the old timber abutment from a previous bridge, which by this time was completely gone, so we were getting washout under there. The repair method again was to install the sheeting, as I mentioned. Sometimes that sheeting goes in pretty easy. These are pretty tall sheets. They're creating a true abutment and not just a cutoff, and sometimes they don't go in so easy. And this sheet is number 3. It's not going in very easy. It took them a day and a half to overcome this obstruction it was under there. This is a third one we did. This is Marsh Road over Marsh Creek. We did this in June, July of this year, and here you can see the sinkhole on this side. Here you can see a little better picture of it, and when they looked inside of it, it was quite deep and extensive, and they had to close the road down for a couple days to fill this, do a temporary patch, and then they reopened the bridge until we could get out there and and do the repair. And this is what the repair consisted of. In this case, we had a tall concrete abutment on piles. There were about 10 piles were down about 10 feet. So in this case, we put galvanized sheeting in. We did the same thing. We built a concrete cap and did a positive connection to the abutment wall to seal that area off. This was the fourth one we did, and this is where we used the foam injection. Pointing here to where it is, it's in central Delaware in Kent County, kind of close to Milford, Harrington, and south of Dover on a Carpenter Bridge Road over Murder Kill River. Interesting enough, this is a plant here, ILC Dover, which does a lot of work for NASA. Most notably are the spacesuits that they've developed for NASA. So it's right down the street. We were doing something new, and ILC is always doing something new, looking for new products. We took a giant leap, just like ILC and NASA, and tried something different. I'll point out one of the reasons that drove us to do that, or a couple of the reasons. This is a picture of the bridge there on Carpenter Bridge Road and the patch. And we've been repairing this patch, I said here in the slide, 10 years. It's been probably since at least 2012, so maybe longer. It's only on one side. They patch this area several times a year, actually. Kind of held off doing anything about it because we have a dead man anchor system behind the abutment. Here's a picture of the abutment, and what we have is we have precast concrete panels that go down about 10 feet from the deck at the abutment. And then there's a timber sheeting system below the panels, which goes down another 12 feet. Underwater inspection found that we had holes in the timber paneling, timber sheeting down here, and that's where we were losing the fill. Before we came in and did a repair, we needed to seal up these holes as best we could. Jason Hart, who's came up with a great idea of doing dumpster dive in our sign shop, collected all these signs, which we took out there, and we had a diver install those signs in the mud in front of that timber sheeting. We're pretty good. This is a picture of the abutment here. Bridge was built in early 60s, probably about 1960. It has timber piles with cables going back to a dead man system. And if we had done our traditional repair, we would have had to cut those cables, expose those cables, cut them, maybe reinstall them or not. Most likely try not to reinstall them. We actually had a design in place to do a sheet pile wall along here. We held off on doing it for a while until we came up with this new idea of using the foam injection. We got the project started in not that long ago, in mid-August. Prime contractor, Eastern Highway Specialists, they're our structure maintenance contract for our Central District area, subcontracted to Eurotech out of Houston, Texas. But they do a lot of work in the Northeast. And we had heard about Eurotech because they were doing some other foam injection for some other applications, not abutment stabilization, that we were doing in Delaware. And we actually have them on task to do several other different applications, nothing like quite like this though. First thing they did is came out and did cone penetrometer testing. I'm not sure what we got out of that, but they find out how soft the soil is. Pattern was developed to drill holes on a 4-foot grid, so all these holes are on a 4-foot grid across the road and down the road. At each location, they drilled 3 holes. They drilled one at 12 feet deep, 8 feet deep, and 4 feet deep. For the first 3, they went 12 feet, and then for the last 3, they only went to 8 feet. They went shallower. And here you can see they drilled these holes, and they installed a rod and a tube. The rod they drilled down, and the tube is what they injected the foam through. And the tube was sacrificial. I think the rod was removed. Here the guy is injecting the foam. They also have a benchmark elevation device here so they can detect if they're actually lifting the road, the pavement, while they're doing this. But he'll inject until the foam starts to come out the top of the port, or 2 minutes if it never does eject out of the port, which in some cases it didn't. It's a 3-component system. 2 are liquid and 1 is air. So there's 3 tubes coming down here to his injection gun. You know, sometimes the foam doesn't come out the port, it comes out somewhere else. Sometimes it comes out someplace else in a bigger way. So these were pulled out of the water. We didn't want them drifting too far away. I think on day 2 we found one coming back on the tide cycle back to us. We collected it, of course. But we pumped 8,000 pounds, And that's about 2,000 cubic feet foam that was placed underground. It only came out into the water the first day. We did it for 3 days, so we sealed those up. This is a kind of a comparison of cost and time on the various projects. So our highest cost was there on Round Pole Bridge Road, and that was $212,000. I divide these by two. We did both abutments there, and at Carpenter Bridge we only did one abutment. You know, it was 3 weeks, 8 weeks, 8 weeks, and at Carpenter Bridge we spent the least amount of money, and we were there only 1 week. We only had a detour in place for 1 week. So in that way, it was pretty successful. We'll continue to monitor it and see how it works out. Cost for the material, $7.50 a pound. We injected 8,000 pounds. The sheeting cost is about $85 a square foot. Continue to monitor this and see which way, make sure this works well for us, and if it does, I'm sure we'll try it again. Any questions?
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.